Mr. Pelton. This is Math 155, Chapter 3, Section 4 on logarithms. Okay, so now we're going to do some word problems. Now we've learned how to solve equations, and what you need is going to vary from problem to problem. So there's lots of ways you'd need logs to solve equations. We're going to just use the financial ones in this chapter uh, as far as application goes. So we had our typical formulas of A equals P 1 plus R to the T if there was no compounds other than yearly. If you had more than one compound during the year, you had to use this formula, which N is number of compounds, and this formula, PERT, PERT, if you had continuous compounds. It has to be one of those three formulas. Okay, so in this case, if we read the problem, we have $25,000. We want to grow it to $500,000, and it pays 9% annually, compounded monthly, which says 12 compounds. So we need this formula here, which is, whoops, let's turn this on. Okay, A equals P1 plus R over N to the NT, because we have 12 compounds per year. So we need that N. So it is $500,000 is the amount in the N. The original principal is $25,000. 1 plus the rate, which is 9% over the 12, and 12 times t. So the thing is here, don't round, and don't round until the final answer. Okay? If there's rounding involved, wait till the end. If it can be simplified, simplify. Okay, so we'll divide out the 25,000. Again, you do add subtract step first, but there is no add subtract step here. So that's going to give us 20 and 1 plus 0.09 over 12 to the 12t. So the inside of these parentheses can be simplified here to a nice rational answer. If it was not rational and involved rounding, don't do it. But since I can do it here, I am going to. So I have to do the division first, then the plus 1. So 0.09 divided by 12, then add 1. I'm going to get 1.0075 to the 12t. So at this point, pick any log that you want. Okay. I'll just pick regular old common log. We'll do common log to both sides. So common log of 20 equals the common log of 1.0075. Let's put the decimal in there to the 12t, so I can bring the 12t down now. So it's log of 20 equals 12 times t times the log of 1.0075. So you notice that the log and the 12 are just constant numbers. So you can divide those out now. So 12 and log 1.0075. And on the other side, 12 and log 1.0075. So in fact, t equals the log of 20 over 12 times the log of 1.0075. So these almost never work out perfectly. This one is 33.4 years with some rounding. That's how long it'll take to make yourself $500,000 from 25, which is a lot. So that's why it takes so long. And if you plug it back in the 34.4 years, you won't get exactly 500,000. You'll get slightly less, I believe, because of the way I rounded it. So um, going out several decimal places is what's really needed here to get more of an exact answer, because when you're dealing with these large quantities, rounding is the worst thing you can do. All right, pause the video, try the student problem for yourself. Okay, so now we have quarterly interest. So we have $3,600 is the goal of what we're trying to make here. That came out sloppy. I don't know why that is. That's better. The original principal is 1,000. We don't know the rate. That's the question here, right? We don't know that. And we know it's compounded quarterly, so that's 4. So that's 4 times the number of years, which it says it's 6. Okay, so we'll divide by the 1,000. So we get 3.6 equals 1 plus r to the 4, 24. All right, so you need to bring that 24 down somehow. So you need some kind of log. As to what log you use, it's really your choice. So I'll just use common log or natural log. It tends to be the easiest instead of picking a specific base. Okay, so that'll be 24 times the log of 1 plus r over 4. So now I can divide by the 24 because I used the power rule to bring down the 24. So we have log of 3.6 over 24 equals log of 1 plus r over 4. So again, we're trying to get the r by itself. So now we have a log on that side we need to get rid of. So what log is it? Well, it's common log because that's base 10, right? So you do base 10 to both sides. So I get 10 to the power of, let's see, log of 3.6 over the 24 equals 10 log of the 1 plus r over 4. Okay. So as a result, that's going to cancel there and leave me with 10 log of 3.6 over 24 equals 1 plus r over 4. So we'll subtract 1. So 10 to the log of 3.6 over 24 minus 1 equals r over 4, but we'll just multiply both sides by 4. So that'll cancel, but the big thing here is it's the entire side being multiplied by 4. Okay, so let's plug this in the calculator and see what happens here. So the way you plug it in is very important. You have to be careful on this. Oops. All right, let's make a clear document here. Okay, so we'll do the innermost first, which is the log. So 10 to the power of, so it needs to be in a fraction or using parentheses. The top part is, let's say, common log. Whoops. 3.6 on the bottom is 24. And the whole thing is subtract 1. Okay. Don't round. And then times that by 4, because the whole thing on the outside is times 4. And you get 2.19288. I think we did something wrong here. Nope, I think we're good.